Okay. Sir, we can ask Manoj to present his slides.
Yes, sir. I stopped presenting.
Yes, sure. I'll try.
Okay.
So now, screen. Is this visible?
Yes. Fine. Looks fine.
Slideshow mode is fine, sir?
Fine. Movement is okay.
Okay, sir. Thank you.
You can go to your title slide. You can go to your title slide.
Yes, sir.
Okay. Dr. Priya, can we start?
Yes, sir. Good evening, everyone. I welcome you all for the webinar on knowledge-driven development, a new KM framework with application in software development and maintenance. On behalf of ACM Chennai chapter and IEEE CSI Chennai chapter, I took immense pleasure in welcoming you all for our webinar. The webinar is on knowledge-driven development. So it mainly talks about the two important challenges in current industry, Agile and DevOps, how these challenges can be procured and interfered using the knowledge development, which is a digital delivery methodology. The knowledge structuring mechanism of KDD is adopted in the Agile. The maturity of Agile can move to the next stage. The other challenges is the lack of general awareness among the team of conceptual knowledge around the project. This presentation will address both the issues and explain the KDD framework, which is gaining popularity. Let me introduce the speaker. Our speaker, Mr. Manoj Kumar Lal from Darbhana, Bihar, is graduated in mechanical engineering from BID Sindri and his ME in aerospace from IISc Bangalore in 1997. He joined TCS immediately after IISc and has been there for more than 24 years now. He is a specialist in insurance domain. He has performed almost all roles in software development. He has been close to 10 relevant accreditations on domain and project delivery, some of them being SAFe 4.0 from Scaled Agile Increment, CSM from Scrum Alliance, Foundation Certificate in Business Analysis from BCS, Foundation Certificate in Software Testing from ISTOB, PRIS2 Foundation Certificate from APMG. He is currently focusing on the domain knowledge portion of the KDD and is in the advanced stages of writing his second book on domain knowledge. He claims to evolve generic domain knowledge structure that can be used to learn multiple domains. As such, it gets well with the curriculum of software engineering. I welcome you, sir, and I also welcome all the participants who was enthusiastically joining the webinar. I welcome you all once again, and I hand over the session to our chief guest. Manoj, sir. Sir, you can.
Yeah, I can start.
Yes,
Yes.
yes.
Okay, yeah. Thank you so much, Dr. Priya, and thank you so much, Sakthivel sir and Mohan sir, for giving me an opportunity to talk at this forum. But it's interesting to recall that 3 years ago I got in touch with Mohan sir, and then he constantly encouraged me to carry on with whatever I'm trying to do out of my passion. And today, I mean, I'm privileged and grateful that he has given me an opportunity to speak at this prestigious forum. So, thank you, sir. Before I start with this discussion, a little disclaimer that these views are my personal views. So it doesn't represent my employer. And with that, we'll start. Okay, so knowledge-driven development. When I started on this journey around 10 years ago, it was looking like a project delivery methodology. And it was a project delivery methodology till 2018, when a book on the same was published from Cambridge University Press. But then it had seeds of knowledge management. And we since then tried to progress on the area of knowledge management. And as of now, we can claim that it is growing and it is maturing as a new knowledge management framework, which is very much trying to gel with the current digital transformation era that we are foreseeing. And it has a good potential to gel along with agile methodology, DevOps methodology as well, but all supporting the entire set of current frameworks and methodology from knowledge structuring perspective and knowledge digitization of knowledge perspective. Right. So with that background, we'll carry on this discussion. We'll look at the main industry pain points that are relevant for our discussion today. And then we give the context of how KDD, knowledge driven development, started, and a little introduction of knowledge driven development. Then we look at this terminology, which is problem space understanding. And then we take a little break and go to academia and say that what is it, what proposition it has to academia, and then we come back and continue our general discussion on KDD as a new project delivery methodology. That, of course, we talk about development as well as maintenance, as clear from the topic of this meeting. We'll sum it up, and we will, at the end, we will see how KDD has the potential to address some of the industry pain points through its knowledge structuring offering. Right. So we start with this. So some of the points that I think is still a pain area in the industry, and the four of them very clear. We have prescriptive and indicative. There's a traditional sort of infighting between prescriptive and indicative. Which one is better, right? Is it better to be planned first and then implement it, or is it better to start doing the work and without spending too much time on plan? But there are areas where one is better. There are areas where second is better. But in general, I think we have been still struggling with finding the optimal balance between prescriptive and indicative methodologies. We'll touch upon that. And in typical software development, contextual knowledge is key. And lately, the organization, industry, as well as academia is waking up to the fact that contextual knowledge is also as important as other skills for the project team. So we'll look at how do we inculcate this habit of introducing contextual knowledge in the project delivery. And this is the typical issues that we have. We have our enterprise repository in the industry where we have loads and loads of documents, but finding the right information at the right time is still a challenge in spite of so much of development in the search algorithm and other things. We still have an issue over there. And lastly, domain knowledge. This is one of the core topics that we will touch upon in this meeting. And I think when we go there, we'll discuss more about it. But we have a fresh and interesting offering in the area of domain knowledge learning. So learning about the industry, learning about insurance, learning about banking, learning about automobile and such industry domains. Now, these pain points, I would obviously agree that Agile has made a very positive influence. However, if we enrich Agile with some knowledge management proposition that is better than what we typically see in Waterfall, we can do wonders in the current era of digital transformation. And this is the sort of basis of our discussion for today. We'll go to the next point where we'll try to understand the context of KDD, which is knowledge-driven development. Right, so in this slide, we very clearly understand that to produce any working output, we need some knowledge about that output, and we need to execute the implementable portion of the knowledge for that output. Right, and it is a generic statement, it is a generic thinking. Whether it is a build, whether it is constructing a building or it is developing a software, you do need knowledge about the product that you are developing, right? And then a portion of the knowledge is implementable. So you need to fix those portions which are implementable. We need to be clear about those portions which are implementable, and then implemented by various execution activities. So this is broadly how a product is developed when purely coming from knowledge management perspective. So in software development, how do we relate it? We related knowledge of the project as various documentations in waterfall area, like functional specification document, requirement document, technical design document, test cases. They are knowledge of the project. And what are execution things? It is coding, build, it is testing, test execution and defect management. They are execution activities. And what are the implementable portion of the knowledge? The implementable portions of the knowledge are technical design and test design. The output of technical design is all the clarity in terms of how the physical entities will be built, your physical databases, your physical logics that you're going to translate into codes, and test cases. You're going to execute those test cases and do the defect management. So implementable portion of the knowledge is not the requirement, not the solution design document. It is technical design output and test design output. So that is how, from knowledge management perspective, we understand how the software is developed, how the software is made. On the right hand side, I think it is a common sense to think that the knowledge is in the mind first, and then we represent it through an artifact, and then there will be activities to implement the implementable portion of the knowledge to create an output. And from quality assurance side, this is typical three things: draft, review, and rework. This is a continuous cycle, and we try to improve upon the quality by using this draft, review, and rework mechanism. So we go to the next, where the balance between knowledge related and implementation related activities is key. And that is where all the methodologies are trying to create. I think all the methodologies are trying to create this balance. But then have we reached a stage where the methodologies are able to strike a balance? From my personal experience, I'm not sure. And primarily, if we see, if a methodology, if a project delivery methodology is knowledge focused, these are the challenges. We have listed out a few things. Some of them are keeping the knowledge updated is a real challenge. The documents need updating at every point in time, particularly in the latter phases of the software development, where there's a more need.
If we request, repeat, please. Thank you.
Manoj, can you unmute yourself? Manoj, can you unmute yourself?
Thank you, sir.
Right, is it clear?
Yeah.
Yeah, okay, yeah. Thank you.
There are two Manoj already.
Right. Okay. Right, so there are both ways. We say in the implementation focused, we broadly indicate towards agile. When it is knowledge focused, we broadly indicate towards waterfall. And there are challenges in both the sides. And over there, we claim that our methodology, our project delivery methodology, is trying to strike a balance which is more visible on at least on the paper, because it is not yet implemented methodology, so we don't know how it will behave when it is practiced in the ground. But at least on the paper, we think that it is more close to striking the balance between knowledge and implementation portions of the project delivery. Primarily because in Waterfall, we have seen there are issues with implementation area, because there is a lot more complex change management track and planning and tracking mechanism, sign-off processes. And in the agile side of the world, we understand that exhaustive knowledge management is not there. We have it in bits and pieces in terms of story points and acceptance testing. But agile as a philosophy itself doesn't ask us to go to the exhaustive knowledge management area. It tells us that you write documents, you write the pieces of knowledge only to the extent that the Scrum team is able to continue their discussion towards design, development, and testing. And let's not waste time in trying to be prescriptive on the knowledge management side. So that obviously means we don't have the exhaustive knowledge of the project in agile. And agile, I think it's fair to say, it doesn't encourage that. Now, in KDD implementation side, we are all good for agile. We say agile is excellent. We adopt the implementation approach of agile. And on the knowledge management side, we have evolved an interesting knowledge management framework. And we say that we have been able to digitize the knowledge management. And that is the core proposition of KDD, knowledge-driven development. Based on that, we claim that we can go much deeper than what is possible today in the agile world. And that is why KDD can be a separate methodology. It can be a proposition to agile, that agile can be enriched for knowledge management side of it using the digital knowledge management framework of KDD. So this is the context and background from which KDD is evolving. We'll go to the next topic now. Just a second. All right. Which is introduction to KDD, introduction to knowledge management. So we said in the beginning that knowledge management framework, KDD, is trying to digitize the knowledge. But then first question is, what is knowledge? Now, in KDD, we visualize three levels of knowledge. First one is domain knowledge, second one is enterprise knowledge, and third one is project knowledge. Now, domain knowledge is knowledge of the industry, knowledge of insurance, knowledge of banking, knowledge of retail. They are domain knowledge. Enterprise knowledge is knowledge of the organization. So knowledge of LIC is enterprise knowledge, which is related to domain knowledge of insurance, right? So this is how we understand it. Now, enterprise knowledge needs to be kept updated at all points in time to remain competitive, right? This is how organization maintains its edge over its competitors by through an optimized enterprise knowledge. Now, how does it do it? It does it through multiple projects and programs and initiatives, whatever name we call it. Typically, we call it as a project. Now, to deliver a project, we need some knowledge. That is project knowledge. We have just touched upon it earlier, saying that different documentations are project knowledge. So that knowledge we are talking about. So to deliver a software project, we need knowledge, which is project knowledge. And project knowledge is a transient piece of knowledge. Because once the project is delivered to the enterprise, project knowledge comes back and seamlessly gets integrated with enterprise knowledge. Now, this is a common sense. Everybody can understand it, and there's no problem in sort of appreciating it. But the problem is, in real life, it is not so easy. although the renewed software has come back into the organization, enhanced software, the customer services are able to implement those new processes that the software has brought in. But from the knowledge management perspective, all we see is loads and loads of artifacts, either in our portal or in our tools like TFS and other repositories, project repository tools. They are there, and they are not readily reusable. And this is one of the problem that we are struggling with in the industry, that the outputs of project knowledge are not readily reusable. So there, there lies our challenge, and KDD has got a solution to it. Subsequently, when we look at the details within KDD, we'll come back to this point again, how KDD is trying to resolve it. But over here, I just want to reiterate that these three levels of knowledge are fit for purpose, right from our graduation in academia up to our retirement in our professional life. Because once we are in the in the academia, we try to learn different domains, and once we are into industry, we deal with two types of work. One is executing the existing business processes, which is run business. That is predominantly the business process area, BPO area. And in the change business area, it is primarily the IT function, where we try to enhance the existing software or create a new software. And from business side of it, we launch new products. We modify existing products, features. We modify existing processes. So those things are in change business area. The typical execution activities will happen in run business area. That is where our enterprise knowledge comes as important. And in the change business area, where we execute projects, project knowledge is important. Right. So with this background, let's go to the next level. And this this is again trying to appreciate these three types of knowledge, three levels of knowledge. Now, in the domain of password management, password should be strong enough so that it cannot be easily deciphered. Is domain knowledge, is industry knowledge, is knowledge about password management. But then once we are in an organization, we cannot we cannot just say that, okay, it should be strong enough, right? It has to be prescriptive. So it has to say it must have 8 characters or 10 characters or 6 characters, whatever is the organization policy. So this piece of this statement is an example of enterprise knowledge, that the password must be 8 characters long. It must consist of alphabet, numeric, and special characters. So this particular statement is an example of enterprise knowledge. Now, what is project knowledge? Project knowledge is trying to enrich the enterprise knowledge, right? So if there is any issues in the enterprise knowledge, it will try to fix it. So one example of the issue can be that currently the mail doesn't go to the user if he changes the password, and we have to fix it. That would mean there is a requirement to send an email to the user immediately after he or she changes their password. So this will be done as a part of a small project, right? So this type of statements or this type of knowledge is categorized as project knowledge. So this is just to re-emphasize on what exactly we are talking about by example for these 3 levels of knowledge: domain knowledge, enterprise knowledge, and project knowledge. Now let's go a little bit further into this interesting area of domain knowledge, enterprise knowledge, and project knowledge. There are 3 Okay, I think the arrow is a little bit misleading over here. It is just 3. There are 3 building blocks that represent domain knowledge, and there are 5 building blocks that represent enterprise knowledge, and there are 7 building blocks that represent project knowledge. And it is inclusive. So 5 building blocks of enterprise knowledge is included in the 7 building blocks of project knowledge. And similarly, 3 building blocks of domain knowledge is included in the 5 building blocks of domain knowledge. And these building blocks provide us the structure to capture fit for purpose information about these 3 levels of knowledge. Now let's look at it in a little bit more details. This is key for our understanding, and this is the key for the KDD proposition as well. Every domain or every industry has got some offerings. We call them as products. And then every product will have a life cycle, and this life cycle would start with launching of the product, administering of the product, and it can go up to decommissioning of the product when the product is withdrawn. These set of activities are called processes. Right, I'm just trying to explain these building blocks that I have written on the left-hand side. So products are offerings of the domain. Processes are life cycle activities of the products. And rules are statement of facts and any statement which is adding to the knowledge of the products and processes. So these are in general all the statements which are throwing some light or throwing some details on products and processes. They are rules, right? So with these 3 things, we can capture domain knowledge, which is fit for purpose for our work. We move on to enterprise knowledge. So the 3 building blocks of domain knowledge are customized for an organization. That is the first thing that it has to do. And the second thing is it will have 2 additional building blocks. The first one we'll call it as usage, which brings in the differentiator of the organization. The examples of usage are, there's a section slide over here which will tell that anyway. But the examples of usage are communications, which is the branded letters that go, let's say you have got a policy and the policy document goes out to you as a customer. The individual, the details of the wording of that policy document is an example of usage. Another example of usage will be various reports that an organization needs and produces for their workers and for their higher managements. And users provide you a mechanism which will help you to create and maintain the distinction as an enterprise. So how LIC will be different from other insurance companies, right? Because all the insurance companies will have to send the policy document, right? So it is different usages which enable an organization towards their own brand, towards their own distinctiveness, towards their own competitive advantage, right? So that is usage. Examples are communications, reports, and such things. IT applications are interesting because this is IT application is only trying to bring in sensible automation to all the 4 building blocks that we have seen earlier. That is all IT application will do. And enterprise knowledge consists of customized domain knowledge, and additionally 2 more building blocks, users and IT applications. We come to project knowledge, where again 5 building blocks, wherever applicable, they will be pulled into the project knowledge. And additionally 2 more building blocks will be there. One is requirement and other is test cases. Requirement only tries to pick and choose out of the 5 building blocks, what is needed? Do we need to decommission any product? Do we need to get rid of any IT application? Do we need to modify any rule? Do we need to tweak any process? So requirement is not a pure knowledge as such. It is only piggybacking on the existing 5 building blocks of knowledge. It is only trying to tell you that what do we need to do about those 5 building blocks of knowledge. And test cases are just reformatting of the requirements just to ensure that before we accept the software into our enterprise, we can confidently say that the requirements are met. Only to say that the requirements are met, we need test cases. So for all this reason, test cases are again not new pieces of knowledge. In fact, the new pieces of knowledge are only 3 things: domain knowledge, which is rule, process, and product. Even usage is tweakings of the rule, process, and products. IT application is technology area anyway. Requirements are not a new piece of knowledge. Test cases are not new piece of knowledge. Now, this insight is very interesting because that is the core of knowledge-driven development. We go to the next slide and see that, yeah, we have understood the building blocks, but then how do we represent the knowledge? Now, the knowledge is represented by inventory and relationship concept, which is a very popular and known and stable concept of graph theory, nodes and edge theory, which says that and in this area of KDD, we say that every inventory is atomic piece of knowledge representing one of these 7 building blocks in the project. So inventory over here is a piece of atomic an atomic piece of knowledge which relates to one of the 7 building blocks of the project knowledge. And relationship is only linking inventories together. So the knowledge structure that KDD has come up with is in the form of inventory and relationship. The entire knowledge is captured in the form of inventory and relationship. Inventory is atomic piece of knowledge. So there's a little sentence which talks about a rule. There's a little sentence or term which talks about a product. They are inventories. Relationship is this rule is related to that requirement, and this requirement is related to that test case. These are rules. So inventory and relationship form the digital knowledge of KDD and tag to one of these building blocks. This is how KDD claims that it is trying to digitize the knowledge. It is trying to structure the knowledge. Now, this knowledge part of it, how about quality assurance? Now, the first thing is a little bit of quality assurance can be done by the model itself. So, for example, if test 01 is a test case and it is not related to any requirement, the model itself will be able to tell us that, yeah, test case 1 has got some issue because it is not related to any requirement, right? So, this is a common sense. And now nobody has to go and find it out. The model itself will be able to tell you. So this is automated defect handling, we claim. And at the end, we all have to rely on the our manual review. Manual review is the last resort. We have not made any tool as of now, which can say that I don't need any manual intervention when we are in the project delivery side of the world. So manual defect mechanism cannot be ruled out. So with manual defect management and the automated defect management that the model itself provides, we do quality assurance side of the digital project knowledge of KDD. But the real knowledge is only inventory and relationship of the various building blocks. Right. So this is how knowledge, along with its quality assurance, is handled. And I would think now the time has come to define KDD, knowledge-driven development. It is a knowledge management framework, as you have seen, to digitize and manage domain, enterprise, and project knowledge that in turn accelerates execution activities, leading to producing a quality output. So this, I think by now we have understood what is KDD and why KDD claims that it is trying to structure the knowledge which is currently not present. Now we come to a terminology which is problem space understanding. This is all about. Okay, well, let's go to the slide and then try to understand it. Now we have said in the beginning that domain knowledge is very important. So this is where we try to bring out the importance of domain knowledge in software development. And it is interesting to say that in the primitive software development is focused on problem solving that we still find in academia, where let's say through an internship project where we can spend 4 to 5 months, we start with a very nice and beautiful idea, ambitious idea, I would say, and then after 3 to 4 months, when we see that there's no progress made, we cut short of the scope itself, and so that by the end of 4 or 5 months we have something tangible to demonstrate. And this is a typical problem solving area where the main driver of software developments are our technology skills, so our understanding of language, our understanding of databases, right? So they drive the software development, but this is ad hoc, and they cannot create a repeatable and reliable software that we can think of using in industry. So there comes the discipline of software engineering, where we say that no, you need to know how the requirements can be managed, you need to know how the project is managed, you need to know how the configuration management is done, how quality management is done, how coding and reviews are done, how testings are done. There is a way of doing that. That is primarily being taught in software engineering syllabus in academia. So that takes us from problem solving maturity to problem understanding maturity, where we read the requirement document, we understand the requirements to some extent, and then based on that understanding, we create the software, which is what I think majority of us are there at this point, problem understanding. There's one more level further than that, which is problem space understanding. So there we say that, look, the project delivery team can not just clerically and mechanically try to read and maybe understand the requirements. They are already equipped with the understanding of the domain around which this software is being built. Right. So it, as we can see in the first line, problem space understanding is about knowledge of the larger context around which the specific problem is being addressed, is catered to. Right. So if the project team knows little bit, not little bit, fit for the purpose is the proper term. If the project team knows the fit for purpose domain knowledge around which the software is being built, it will be a better quality work. It may be done in a less effort, in a less rework with more quality, and it will be taking us to the next level of maturity in software development. And that is what I think industry is progressing towards. It is progressing towards an age where we know at least as much as our customers know about their domain, so that there's no gap between the software that we produce and the software that they need. Right. So this whole area is called problem space understanding. Now there's a little bit explanation of problem space understanding, but looking at the time, I will not try to read it. We'll go to the next slide because I'm less than half in my full set of slides. We'll go and revisit this whole area of 3 levels of knowledge and working software. The things on the left-hand side, which is domain knowledge and enterprise knowledge, they fall under problem space understanding because they give the context of the software development. And on the right-hand side, which is the real software development, which is where the real software development happens, it is primarily driven by project knowledge. Now, project knowledge is enabled by problem space understanding, which is domain knowledge and enterprise knowledge. And KDD has made it possible in a very transparent manner that how domain knowledge and enterprise knowledge actually comes in and enables project knowledge. That I think we'll learn in the subsequent slides. So we will go to the next slide. But then one thing is important to understand here is enterprise knowledge we cannot discuss in the open forums because it is a proprietary of an organization. So we can say that problem space understanding is primarily to deal with domain knowledge, at least in the academia and industry forums, where we cannot talk about enterprise knowledge. And knowing domain knowledge is enabling us towards going towards problem space understanding area. Right. So it is domain knowledge which is more important and to be focused because we can't go into enterprise knowledge area in the open forums. Right. So with this knowledge, we come back to a typical form of representation of enterprise knowledge. I'll not go too much into it. I will only say that there are 5 building blocks as we have seen earlier: rules, product, processes, IT applications, and usages. And this is the digital representation of enterprise knowledge that can potentially solve many problems that we face today. But let's not go into the details of it right now. Let's come back into the area of domain knowledge, which is this is a typical representation of what we already have discussed. That every industry will have an offering that is product. Every product will have a life cycle that is process. And at the intersection point of product and process, there will be statements which are primarily rules, but there are statements of knowledge. There are lines of knowledge, there are sentences of knowledge, there are atomic pieces of knowledge, which is mostly in the terms of inventories of rules. Right. So this is how domain knowledge, we can think of structuring domain knowledge in this format. There will be a 2-dimensional mesh, one of product, another of process, and at the intersection point, we have many statements of knowledge, which are atomic pieces of knowledge, which are inventories for the domain, for the industry. We'll have examples, so let's not worry too much if we have not got it fully. We have examples over here. So level 1 domain knowledge of insurance and automobile we'll quickly see. So in one dimension, we have products. So for for insurance, the level 1 products are reinsurance products, health insurance products, life and pension products, property and casualty products. And the level 1, the highest level of processes will be launch process, administration process, and decommissioning process. So that is level 1 diagram of insurance domain. Similarly, we have level 1 diagram of automobile domain. So at the highest level, categorization of products will be personal vehicle, commercial vehicle, and special purpose vehicle. And on the process side, we have 5 processes, right, starting from product engineering to sourcing to manufacturing to sales and marketing and to servicing. Right, so this is level 1 domain knowledge structure. And the interesting thing is it is hierarchical. So it can start from level 1, it can go to level 2, go to level 3, go to level 4. whatever level is appropriate for the subject matter experts of that domain, it can go up to that level. And at the lowest level of details, it will then start writing rules, which are the real knowledge for the domain. Right. So till then, it will only keep dissecting itself to the next level of detail. So there's an example from banking. We are seeing the level 2 diagram of banking, because level 1 will have your retail banking, commercial banking, and investment banking. If we dissect retail banking, it will be the next level diagram, level 2 diagram for retail banking, which is advanced type of accounts and deposit type of accounts. Launch admin decommissioning is the process at this level. And level 2 can go to the level 3. If deposit account is broken down, it will be 3. This is for illustration purposes. So it will have 3 next level accounts. So savings account, fixed deposit accounts, and recurring deposit accounts. And the launch of deposit account is dissected. So administration also is dissected over here, which is account opening, account administration, customer administration, and account closure. Right. So this is the level 3 diagram. It can even go to the level 4 diagram, depending on the need of the organization. Right. So this is how this hierarchical nature of domain has given us multiple unique opportunities, both in industry and academia. We'll come back to this a little later. We'll go to the next slide, where through an example we will see how the real domain knowledge is captured. So let's say if this is the last level of hierarchy, account opening of savings account, how do we actually capture the real knowledge? So real knowledge is captured in terms of rules. So rule 1 to rule 9 are over here. And what are the actual rules? So one typical rule is this: the initial amount must be deposited for opening an account. So as you can make out, every single sensible statement which are related to this process and this product should be written as rules in this particular order, fashion, structure. And this gives us an ability to understand industry knowledge or domain knowledge, which is fit for purpose for our software development requirements. This is a very big statement. We probably need to go offline and look at it properly and a little bit more into details. But this is our claim. Our claim is, you go to the lowest level of hierarchy in product process mesh area. At the lowest level, you start jotting down the individual inventories of knowledge base, atomic pieces of knowledge, of rules, and that becomes your fit for purpose domain knowledge. Right. So at every single intersection point, if they are relevant, you need to do this exercise. Once you have done this exercise for every single intersection point, you can claim that you have a fair understanding about this particular domain on which you are doing this exercise. Right. Now, this gives us a beautiful proposition for academia. And what is that proposition? A very interesting proposition. Now, academia today, industry needs 3 skills for someone to be productive on day 1. They need technology skills from students, soft skills, and domain skills. Right. Now, this is needed at the first assignment when a student joins an industry. Technology skills, domain skills, and soft skills. Now, domain skills are largely untouched in academia, but this is for a very common sense reason. How will you teach domain in academia? Will you start teaching insurance? And if you start teaching insurance, why not banking? And if banking, then why not automobile, and why not retail? There's no limit to that, right? And how much depth will you go in teaching? This is very subjective, right? If you do at a very superficial level, there's no benefit to anybody. So that led to a popular belief in academia that students will learn domain knowledge anyway on the job in industry. And because we can't readily teach them, we'll not teach them. We'll leave them to get trained in industry itself when they are working in the industry, right? Now, against this popular belief, KDD domain knowledge structure gives us a scientific proposition. And what a scientific proposition is? It is seeding the domain knowledge in academia. Now, what do we mean by seeding the domain knowledge? Now, so over here, the domain knowledge proposition of KDD, we are saying it is it is trying to bring science into the traditional art of domain knowledge understanding. So how do we learn domain knowledge today? We do some courses, we read some books, right? This is how we know domain. We go and sit with, or do we do knowledge sharing sessions where experts in that domain start teaching us that particular domain? This is traditional ways in which we learn domain. But no book on domain will tell you that by reading this book, you will be knowing 67% of the domain, or you'll be knowing 89% of the domain. Because there's no notion of a structure is there today in domain knowledge area. And what we have tried to bring in is we have tried to bring in the structure and notion which is generic, which can be used across multiple domains. So this particular structure that you're seeing, we have seen that this structure is used in banking, in insurance, in automobile, the same structure, right? So this is an attempt to bring science, or at least introduce science to the traditional art area of knowing domain, right? So that gives, and the hierarchical nature of domain knowledge is even interesting, because that gives us the real proposition over here. What we are trying to say is level 1 and level 2 of the domain knowledge structure is something that we can start building in the academia. And level 3, level 4 and other subsequent levels, which is where the details of the domain needs to be understood, that can be easily left for the students to go in the industry and then start learning. Because domain learning is a lifelong process. So, having spent 24 years in insurance, and I cannot claim that I know much on insurance, right? So this is a lifelong learning process if we really want to learn domain. But then what this KDD proposition is trying to bring in is trying to bring some structure to the process of learning domain. And because the structure is hierarchical, we can say that we learn the high level portions of the structure in academia, and then go to the detail level when it is actually needed in the industry. So that is the proposition we are trying to bring in here. So now, if we revisit this particular gap of domain knowledge, all we are trying to say is we will seed the idea of the existence of generic structure in domains. We'll tell them one or two domains at a high level. We will, and because KDD knowledge management framework goes right from domain knowledge up to project knowledge, and even into software development nitty-gritties, we will also tell the students that how domain knowledge actually helps in software development. And using the agile methodologies, we can create a couple of artifacts on the knowledge structure, the domain knowledge structure. So it can be packaged in such a way that the seeding of domain knowledge, instead of starting in industry, can happen in academia. We already have a successful example in BMS College of Engineering for MCA students. We have been able to introduce these 5 topics that I have listed over here. and we completed this their portions very recently, and the faculties and students and the college also appreciated it very well. We can even go to the go to industry and tell them that, look, our students now know a little bit about the domain knowledge as well, in addition to the technology knowledge, technical knowledge. And that is a win-win proposition for academia as well as in industry. And this is trying to bridge an open gap which is there right from decades and decades, that we have not been able to introduce our students to the area of domain knowledge, knowledge of insurance, banking, and other things. And that gap can be plugged by introducing this particular idea of learning the structured domain at a high level, understanding how it helps in software development, and then leaving the remaining detailed understanding of domain knowledge for the actual work when we go and join the industry. So that is where the domain knowledge has got an offering for academia. Now, how much time I have? Sorry, it is already 7 o'clock. It is showing. Mohan
No,
sir?
go ahead. Don't worry about the time. You can go on explaining the things. No?
Is it
Because we want to
interesting, a
learn.
general
Yeah.
feedback? Because in next 15 minutes, I'll try to finish it. But in general, it is okay, sir. Speed and
Yeah, definitely,
understanding.
definitely. Because the topic is relatively new, and then people are understanding. So go ahead, please go ahead.
Okay, thank you very much, sir. Now we have learned about the predecessor activities of software development. We have learned about domain knowledge, enterprise knowledge, and that type of things over there. Now let us talk about KDD as a new project delivery methodology. So right into the area of project knowledge and how it actually helps us in software development. The first thing that we do is we customize or we expand our project knowledge from the generic set of building blocks to specific building blocks suitable to our traditional software development area environment. So over here, if you see, the processes are broken down into two levels, process and process steps. The usages, as I was indicating earlier, that there are multiple usages. Now the usages are, examples of usages are non-functional attributes, business data, communications, reports, screens, messages, offline transactions. The examples of IT applications are the real applications itself, then the constituents of IT applications, which is in the terms of data and logic. When we say data, it may be physical table. When we say logic, it may be methods and such things. Test cases are just test cases, requirements are just requirements. So 7 building blocks of traditional or generic project knowledge gets expanded into 16 building blocks of software development related constituents. Now, the other interesting thing is how these building blocks are related to each other, trying to understand it from the 4 viewpoints of project knowledge. Now, there are many interesting revelations here. The first thing is these four blocks, they represent complete knowledge of the software from 4 different points of view. 4 different viewpoints. From requirement viewpoints, we have 6 building blocks that give us a requirement viewpoint. There are 7 building blocks that gives us solution design viewpoints. There are 2 building blocks which gives us application design viewpoints. And test cases are just test cases. Right. And if they are complete visualization of the project knowledge, what do I mean by that? What I mean is, if you know every single test cases for the project, you do not find any new piece of knowledge either in your application design area or in your requirement analysis area or in your solution design area, and vice versa. If you know every single thing that you need to know in the requirement analysis area, there's no new piece of knowledge in solution design area, application design area, and test design area. Right. So that obviously justifies the relationship between these four containers. Right. So if they represent complete set of knowledge from four different viewpoints of the project, there must be a relationship between them. Right. They are not unrelated. Now, what is the relationship? The first one is between requirement analysis and solution design. The relationship is transformation. The relationship is in detailing. So if there are 5 units of knowledge in requirement analysis area, the same knowledge is expanded into 15 units. So it is just the quantity that is the differentiator here. So instead of 20 statements, we have got 50 statements over here in the solution design area. They're just expanding. They're just putting more and more details into the requirement analysis piece of knowledge. That is your solution design area. Solution design area is in business terminology that needs to be converted into technical terminology, right? Java, Python, and that terminology. And that happens through the mechanism of conversion. So convert is the relationship between solution design and application design. And test design, again, is in business terminology. Solution design is also in business terminology. So there's no real mapping happening between these two areas. It is just reformatting and reusage. Whatever we know in this solution design area, if they are testable in the format that are written in the solution design, maybe there's no need to create any additional set block of test design. Right. So this is a very, it took me multiple years to understand this particular relationship and the notion of completeness of this 4 viewpoints of project knowledge. But once I understood it, it gave me a very good clarity in terms of how can we improve upon the existing methodologies, and that is how KDD has come up with this particular proposition that a new project delivery methodology. Everything that I have said is probably explained in terms of this example. It says that, okay, let's take one requirement analysis inventory and see how it is expanded in solution design area. So like the message date of birth is not updated is not probably a piece of knowledge for requirement analysis phase. It is a piece of knowledge for solution design phase where we are expanding on the gist of requirement which we are putting it over here. So this is where the transformation or detailing happens in solution design. And as you can see, there's some terminology used here on technical side of the world that it's a conversion. You can say these 3 things are getting converted into one, but many to many mapping can happen between them and this reuse. So this is an example just to illustrate what I have said earlier. And in the beginning itself, we said that KDD says that do project knowledge in the digital format and pick up the implementable portion of the knowledge, which is application design and test design. Do some execution activities, which is build and test cases. And then software is ready. You just deploy it. Now, it looks generic, but then if we visualize the essence of KDD, it will become very clear that it is, although it looks generic, it is practical. Maybe it can be done also. Because all KDD knows is inventories and relationships. As we have said earlier, this is how the knowledge is digitized. This is through automated and review mechanism. We do quality assurance on that knowledge. These are our implementation activities through which we do testing and build. And if we do it as transparently as these numbers, we can do wonders in IT projects. So we can bring in digital transformation itself in our IT project delivery. Now, many people can say it is all theoretical, it will not work, but I know it will work if we bring in the right sort of context to the project team. If the project team will make it work, but then we need to tell them properly why we are trying to do that and what advantage it is going to get us. Because once the knowledge is quantified in this particular format, every single set of information that we traditionally see in these artifacts are actually there in the very traceable and atomic basis in these inventories, and you can easily extract every single information that you need from your reporting perspective, from your project progress perspective, from your traceability perspective, from this quantified inventories of project knowledge. And this has been made possible. This is a very simple slide which tells us that, look, knowledge evolves in a way which is not very consistent in waterfall and agile both areas. So in waterfall, we assume that most of the knowledge we know right first time, which is not correct. And in agile, we just start our implementation activities even without spending too much of time, or not too much of time, even without spending the necessary time to work out on the knowledge and implementable knowledge portions of the knowledge evolution. So knowledge is not matured and you have started implementing. So that is also not correct. The natural knowledge evolution, KDD follows natural knowledge evolution to the best of its intent, and it is able to follow because it has got knowledge in a digitized, structured format. So it is able to follow. Waterfall methodology, even if it will try, it will not be able to follow because they are in the form of analog knowledge, which is documents. Documents cannot be kept updated. Right. That is why the agile methodology is going down in its popularity. But if you bring structure to the knowledge, there is a greater chance that you can keep knowledge updated with this digital knowledge, and that is what KDD is trying to achieve. Right. So that was this particular diagram, and again, re-stressing the same point, and this is particularly interesting for our business analysis community, which says that, look, the way we do requirement management is not via noting down new statements of knowledge. No, this is not the case. We note down that how much of our enterprise knowledge is getting impacted by this particular project through the requirement. So requirement will only say US2 is not needed and IT01 needs amendment and BR01 needs to be deleted. And this tracing mechanism of KDD, which is inventory and relationship, is a very clear indication that the requirements and test cases are just derived information, derived knowledge. They are not the real knowledge. Real knowledge, if you have problem space understanding type of maturity, you would know half or more than half of the knowledge right before the start of the project. And during the project delivery, you may be able to finish the same project with half. I mean, I don't want to make any quantitative claim, but I think that we should be able to produce a more quality, better quality software with the reduced effort if we enable our project delivery via the whole understanding of knowledge-driven development. This small example again to illustrate what these pieces of knowledge are. Industry knowledge in opening of savings account, banking domain. The domain knowledge is savings account is an interest-bearing account, right? This is the industry knowledge. check facility is available for savings account. This is an industry knowledge. Now, for a particular bank, it cannot be left at this stage, right? It has to say that for my account, I will pay you 4% of interest, right? So this becomes enterprise knowledge. This no longer, this evolves from domain knowledge to enterprise knowledge. So this is how this evolution happens. This is how the transformation happens. And again, if check facility is available is a piece of domain knowledge, 40 check leaves will be free in a year, and after that it can be charged 3 rupees per leaf. This is a piece of enterprise knowledge. Okay? This is specific for a particular live account, right? And in project knowledge, so the whole notion of project knowledge is trying to keep the organization knowledge up to date. So maybe when there is a requirement to reduce interest rate from 4% to 3.5%, this will happen through a project, right? So this piece of information becomes project knowledge. And similarly, if there is a need to make all the checks chargeable, again, this is a piece of project knowledge. And after execution of this project knowledge, it will go and merge in enterprise knowledge, right? So see, this is what happens in all the projects, in all the organizations. But then KDD brings in transparency in terms of how it happens, and that is why it brings in loads and loads of reusability. And as we can see over here, this is the slide where we talk about the maintenance side of the work. If let's look at it in development side. So when we do software development, we build A and B. A is inventory, B is relationship. And in the maintenance side, what we do till the software is live and till the point it is decommissioned, the same A and B, we maintain them. So we delete some of the inventories, we add some of the relationships. That is what we do. If it is available at the end of software development, if this project knowledge is available to us in the digital format, the life becomes very simple in our maintenance phase, because the entire knowledge is captured with us in the alternate repository, which is our digital project knowledge repository. The impact analysis, for example, can be done in 1/10 of the time than what we do today, right? So this has got immense potential in supporting the software maintenance and enhancement phase. And as we said over there, automated review and quality review is ensuring that the quality of A and B is maintained. And development, maintenance, and quality, DevOps. So KDD can be used to enable DevOps also from the knowledge management perspective, is what this slide is trying to tell. And I think this one of the last slide, which says that reusability is enhanced greatly if we use KDD, because everything is quantified. So we can measure. Today, many times we say, okay, how many clicks on the existing project documents is a measure of reusability. But that is very subjective and outdated, right? The real measure of reusability is how many inventories have you reused from the enterprise, right? And KDD structure enables this particular reuse. And this puts us in a continuous improvement path, because with every subsequent project, we will have more and more reuse, theoretically and practically also, if we follow this particular structure. So looking at the time, I think we are almost there. Summing it up, as we can very clearly see, there are two propositions of KDD. One is pre-requirement and requirement, other is in the real SDLC. In the real SDLC, we have KDD as a new project delivery methodology. It also enriches agile project delivery methodology via its structured knowledge, project knowledge proposition. And for that, there is a book by Cambridge University Press. I think you will get the first chapter of this as an e-chapter, let's say Cambridge University Press. So this book tells more on the project delivery side of the world of the KDD. I'm writing my next book, which is going to be published next month, which is around problem space understanding, essentially domain knowledge side of the world. So I'm hoping that this book becomes the textbook for the academia who may be happy to introduce seeding domain knowledge for their students. So that and the book is almost drafted. It is in the final stages of getting uh, published. So this is broadly, and these two propositions are loosely coupled. So it is not necessary that if you're doing KDD project delivery, you must use this particular problem space understanding, and the vice versa also. If you know problem space understanding, you are not restricted to using KDD as a project delivery methodology. It can be done. It can be used in any project delivery methodology you follow. And this proposition, the structuring of domain knowledge, is a new proposition which is not there in the market today. But KDD as a project delivery methodology, there are loads and loads of delivery methodologies today. KDD is just 3 years old. And as we know that Agile took almost 10 years before it became practical to be used. I don't know how long KDD, if at all, will take to get mature to that level. But not with not to be disappointed with this particular piece of sort of realization. Over here on the left hand side, we know that domain knowledge structuring is something new that we are bringing it up, and domain knowledge structuring is a new concept. There's no literature on domain knowledge structuring, so we are very much hopeful that domain knowledge structuring will be adopted much faster in the industry and academia than what the reception for a new project delivery methodology will be in both academia and industry. So I think with that, I will not spend too much time on this because all of these problem areas, I think we have catered for, we have talked about. Let's not waste time on that. Let's close it quickly. It's already 20 minutes past 7. Progress so far, we have spoken into multiple forums. This is one of the most prestigious forums that I'm talking to. And we have a site where most of the information on KDD is captured, knowledge-driven-development.com. We have this book that we just talked about, published 3 years ago from Cambridge University Press and ISC Press jointly. And this domain knowledge seeding is already there in the syllabus of BMS College of Engineering for their MCA students. If you go to their site, you can see the details of the topics that we are teaching for seeding domain knowledge. Dream ahead, every single college that teaches software engineering, we think that we can talk to them to see if they're interested in seeding, introducing the seeding of domain knowledge in academia. So that is one of our dream. The other piece of futuristic dream is because the KDD provides a structured knowledge base. I mean, we are sure that it will at some point in time go and gel quite well with artificial intelligence and machine learning, but we have not discovered how. Maybe that is something for the next book to talk about. And we are also hoping that KDD can enrich agile methodology to drive digital transformation, because I would obviously think digital transformation also needs digital project management. So not digital project management, digital knowledge management, which will drive going towards digital project management as well. So with this, I come to my last slide. I'm active on LinkedIn also, so we can get connected over there. This is my number. And for anything and everything that you want to connect to me, I would say Mohan sir and the forum organizers of this webinar, you can connect to them. So thank you so much. I have exceeded almost half an hour from the time, but then because Mohan sir has allowed me to do that, I have taken the liberty and did it. Over to you, sir.
Okay, thank you, Mr. Manoj, for your wonderful presentation on the knowledge-driven development framework with apt example which are familiar to the users. Basically, the banking and insurance, these are two areas where most of the users are personally involved. So your examples were also being very apt in the case of explaining the concepts. And as you have mentioned that KDD is becoming very important aspect in the development process. And there is a question one of the user has asked, very pertinent question. What motivated you to come with this framework?
No particular motivation. So I think it is just a luck and coincidence. When I was so frustrated in sitting in the project delivery teams and then arguing counter arguments. The requirement fellows will say that you have not read the latest requirement, and test fellow will say that no, you have not sent me that. They will say no, I've sent you in the email. The other fellow will say you have not put it in SVN. So it's all blame game type of thing. Not today. I think 20 years ago we can visualize this typical situation.
Yes.
And I was thinking, can't we focus on the same thing so that everybody looks at the same source of reference? So that nobody can have any chance of saying that, where is this and where is that? So I thought, can't we come up with a structured knowledge mechanism so that everybody will point towards the same thing, so that there is a good chances that it will remain correct. Because if we see, do something, somebody has written some documents, but then nobody reads it, right? So they'll come to the business analyst and say, forget what you have written, you tell me. Now this is the problem, how to sort it out. Right. So this mentality, I think, uh, has inspired me towards good and look for something which is a better way of working.
Yeah, but still, knowledge is power, and everyone wants to hold it to some extent. So,
Right.
so this process, tries to make knowledge is accessible by everyone. Okay,
Absolutely.
so which basically should improve the project delivery and project understanding, and ultimately it will lead to success of a project, and users will definitely will be happy, and also that the enterprise or the business will be quite happy with IT. See, now the IT and business alignment, there is always there's a gap, and
Right.
particularly this type of sharing of information at every stage will be useful for both the business team as well as the IT team.
Right,
So
sir.
that's a great effort.
But
And yeah,
sir, many people say that no, this is all theoretical. In practice, it will not work. You cannot
yes.
force.
In fact, I was about to ask that question.
Right,
In terms of application of this methodology, is there
right, sir.
any at what level or what percentage of industry? Is there any information available about the usage of this particular methodology in industry?
On the project development methodology side, no, there is no implementation of it yet, sir, because Excel sheet is not enough. We need some sort of primitive tool to actually try to do any pilot and that sort of things if we want to project it as a working thing. But in my own personal world, I have experimented it with in the last 6 to 7 years. I know it will work provided there is a positive atmosphere created in the team who can be taught of the importance of this particular thing. And if one or two successful pilots are done, I think then we will have demonstrable things for others to start believing that something like this can also work, right? So that is where we are. But on a sprinkler basis, I have got people getting in touch with me, and we have a couple of implementations of this concept, but they are very primitive and just a crude visualization of it. They are all linked in my website. If we go and look at it, one or two websites are there which is trying to do something on that. But I'm very much positive on the left hand side of my proposition, which is domain knowledge area. Even without the book getting published, we got this included in the syllabus of an engineering college, which is a great, I would think, indication that the left hand side of the proposition is very, very formidable, and it has seen implementation even before any literature available onto that.
Yes. So each, the major developers, major IT companies, individually, each one of them have their own way of documenting the projects, and ultimately, for the reusability purpose and things like that. Okay, so this KDD will be, as you have mentioned, the reusability of the project, and they do have knowledge officers, in the project team, and possibly as a centralized knowledge team, which will be working for across the projects, right? So
Right.
this KDD, does it have an overall structure, or it is project specific?
No, KDD's overall structure is there, and overall structure is its enterprise knowledge base.
Okay.
So, enterprise knowledge base is already there. Before we start a project, we go to the enterprise knowledge and say, look, we will need 20 rules from you. We would need 3 IT applications from you. We would need 3 products. And then we say, as a part of this project, we would also add 1 product. We would also add 3 rules. And that is how we foresee the transparency and reusability being built between enterprise and project delivery. And another important thing I would like to mention here is, whereas our existing methodologies start with requirement, KDD doesn't start with requirement. KDD starts with enterprise knowledge. So the moment we start the project, we say that, okay, how much reusable inventory and relationships are there in the enterprise for us to reuse? What we do today in workshops, we call meetings with all the relevant stakeholders, and then we say that, okay, you sit in this workshop for 1 week. We will try to sort it out, but all they're trying to do is trying to recollect the or retrieve the existing enterprise knowledge. So because today it is not available in a readily reusable format, we spend loads and loads of time to do that. I think startups are a very great example. They can try to experiment with this methodology because they start with clean slate. An existing company might find it difficult because first they have to digitize the loads and loads of document that they have in their portal. But if startup can adopt it, and they can validate or disapprove this concept very easily.
Okay. Okay. There's a question regarding the importance of out of these three knowledges, like domain, enterprise, and project, from quantification and measurement viewpoint, which is more tangible? Is it the domain knowledge, or enterprise knowledge, or the project knowledge?
From which point of view, sir?
From quantification and the measurement point, the project success.
All three are same, because all three are based on the same structure. So in my book that I have written on on automobile, I don't remember the number, but I have said that by reading these 35 pages of the automobile domain, about the automobile domain, you are you have got 3% or 5% of the entire automobile domain knowledge. So This quantification is very interesting and surprising also, because no book can claim that by reading this book on automobile, you would know 67% of automobile. So that is possible now through the structure, as you can visualize. We can go up to 3 level of hierarchy in company 1. We can go up to 5 level of hierarchy in company 2. But both the companies are able to quantify because they have set their scope.
Okay, with a lot of the changes are happening globally, now even the domain knowledge itself undergoes some changes, because of the newer technologies are being introduced. How do you keep the knowledge updated in this framework?
Right, right. Very interesting question, sir. Sir, my personal view on that is the domain knowledge is inherently stable, sir. So we talk about rules, we talk about offerings, we talk about processes. They are not changing. What is changing is channels are changing. Today we are doing. Yesterday we were doing it through telephone by going to the offices. Now we are doing it through apps and we are doing it through portals. So I'm not capturing portals and channels in my building blocks. I'm only capturing the rules. I'm capturing the products. I'm capturing the processes, which will change, but not so much.
Okay. And see, this KDD, is it approved methodology as of now?
Sorry, sir.
Is it an approved methodology as of now?
But how
KDD.
do we decide whether it is an approved or not? Because I don't know.
No, basically, there are some industry associations like ACM, IEEE, Computer Society, they do have user groups, software engineering user group, and they also come out with the software engineering body of knowledge. Okay. So actually in that, the book is called SWBOK, Software Engineering Book of Knowledge, wherein, they specify 15 areas of knowledge related to a software. Okay, there, of course, they break down based on the software development life cycle, plus also the maintenance and further engineering aspects and other things. So there is an extensive book which is freely available as a documentation for anyone who is interested. So, where actually I was just wondering, is that does it fit in anywhere in one of these areas, or it overlaps? If that is the case, can it be referred to these industry bodies and then try to sort of make it one of the accepted, or at least can be debated across the world? So I think
This,
you should
this is
do
a
that.
great piece of information, sir. I would like to be guided with you further on that, because
Okay.
today there's no such group. There is nothing. I am only going to different webinars and trying to say there is a methodology, but
Okay.
nothing of that sort exists. And please guide me to see
Yeah.
whether we can
Okay.
progress in that direction, sir.
Yeah. This IEEE CS, that software engineering group is there. Both ACM is also the ACM SIG and software engineering, and similarly IEEE CS has got a special interest group in software engineering. I,
Oh,
I feel that you should submit your proposal of this KDD methodology, and then it can be debated by the members, and then they can try to include it in the body of knowledge book. Once it
oh, this is
gets,
great, sir.
it gets recognition across the world,
True,
because
sir. True. I
both the bodies are worldwide recognized. That is one thing.
thank you so much, sir. I'll get guided by you to
Sure,
progress
sure.
on this, sir.
Okay,
Thank you.
okay. So,
Thank you.
and then it is interesting that know that this domain knowledge related thing are getting introduced in the engineering colleges for the student
Yes.
purpose. But actually, it is just only one college has started to start with. If I remember, you were mentioning BMS college and things like that, right?
Right, sir. Right, sir.
So, but I think it should become more globally accepted, and that is possible provided you get this framework to be
Recognize.
sort of recognized,
Right.
adopted by other people. Maybe I
Right.
think you should get in touch with some of the universities and then try to convince them And as of now, the software engineering itself is become an optional subject. No, it is still not a core subject in many courses.
Right. Right.
So in the KDD, again, one more level of specialization it becomes. So it becomes a little difficult in terms of making it, or at least you should try to encourage them to run it as a audit course. Maybe
Right.
you
Elective type of course. Yeah.
elective type of thing,
Right, sir.
and then possibly along with working with some of the industry people, if you
Right.
can try to work with them and then provide some internship opportunities for people to get into these areas, and
Right.
that will, long run it will be very useful. So
Absolutely, sir. Absolutely, sir. You have been the witness. We have been witnessing this progress from last 3 years, sir. So I'll remain in
yeah,
touch, and I'll try
sure.
to progress through your guidance further on this, sir.
So thank you very much, Mr. Manoj, for your
Thank
wonderful
you.
presentation. So we
Thank you.
really look forward for your second book, which is focusing more on domain knowledge, which is
Right.
one of the critical knowledge one has to have in order to develop a good software and application. So that will be definitely, we wish all the very best for your second book, and it will definitely will get adopted by everyone. And in fact, even professionals nowadays, their knowledge and domain is quite relatively, because they all work in a specific modules of a project. So they feel that domain knowledge is not that great. So because a large project, when they work on a specific areas or modules, so
Right.
their focus is also limited to that extent. So they don't go beyond that. Provided if they can understand overall structure of the industry and enterprise knowledge and domain knowledge, their contributions can be much better.
Right, sir.
So I'm sure that your forthcoming book will fill that gap between the professionals as well as the industry requirement. That is something great. And at this
Thank you
point,
so much for your progress, sir. Thank you, sir.
I would like to thank Cambridge University Press, Mr.
Right.
Vijay, for his generous offer in making the first chapter of the book being given as a teaser content to all the registered participants, so that to a small extent we will promote the concept of KDD from CSI, ACM, and IEEE CS. So so we'd like
Really,
to,
sir. Thank you.
yeah, I
Thank you
would
so
like
much
to
for
thank both
Cambridge University Press and ISC Press. Thank you
yeah,
to them
yeah.
also.
So we would like to extend our sincere thanks to both the
Sure.
Indian of Science Press as well as the Cambridge University Press. And
Absolutely, sir. I'll pass
once
it on.
again, our thanks for your time and effort in making this wonderful presentation. We really look forward to working with you in some of our future programs. Thank you very much.
Absolutely, sir. And thank you so much, sir. Thank you so much for your opportunity you have
So,
given. Thank you, sir.
I also take this opportunity to thank all the participants for their for joining this program, and we have already made announcement for our next program, which is scheduled on 15th on web engineering. So this is going to be on the subject of web engineering, and which will be tracing the development what is happening in the web related technologies. And please do register and then get benefited by attending this program. So with this, we formally close our today's session. And so good night to everyone.
Good night, sir. Good night, everybody. Thank you all for your participation. Good night. Thank you.
Thank you, sir.
Thank you. Bye bye.